This lecture explains the syntax of creating class and object. In order to create a class, first you should write the class and then the class name. The keyword called class specifies that we are going to create a class, but you should give the actual name of the class at the right hand side. As per the C# recommendations, it is recommended to follow always Pascal case for class name. And you should begin the class by opening the brace and you should end the class by closing the brace. Inside the class, you can declare the class members. Because the class is a model of objects, what data that you want to store inside the object can be described inside the class. So inside the class, you can declare the class members, that is fields, methods, properties, constructors, events, and destructors. So these are all members of the class. But in fact, when you create object, only the fields are getting stored inside the object. But any object of the same class can access the all remaining members, that is methods, constructors, properties, events, and destructors. I will explain about fields, methods, constructors in the further sections of the course. Almost we have separate sections for each member. For example, in one section I will explain about fields, in another section I will explain about methods, etc. At the left hand side of the class keyword, you can write the access modifier. The access modifier is a keyword that specifies where the class can be accessible. For any C# class, you can apply two types of access modifier, that is internal and public. The internal class can be accessible within the same assembly, that means within the same project. So you have created a class called customer, for example, and if it is internal class, you should write like internal class customer. Then that customer class is accessible within the same console application project, but not accessible in other console application or other type of project. But if it is a public class, the same class can be accessible in other projects that are present within the same solution and that are having the reference to the current project. So in short, internal class is accessible within the same assembly, that is in the same project, and public class is accessible everywhere in the same assembly or in other assemblies also. Here assembly can be assumed as a project, and a solution is a collection of projects. In fact, the compiled source code of a project is called as assembly. For example, you created a console application with a set of files. All the code that is present in all the files of the console application will be compiled as an exe file. But in case of class library type of project, all the files are compiled into a DLL file. So these exe or DLL files are called as assembly because they contain the compiled source code of the project in the form of IL code, that is intermediate level language code. I have already explained how the IL code executes in the lecture of CLR. The default access modifier is internal. That means if you don't specify any access modifier, that is by default taken as internal. In real case studies, you will create different layers in the application, such as data access layer, business logic layer, etc. In that case, it is necessary to declare the class in one assembly and access the same in other assembly. In that case, you should go for the public class. But for timing, for practice level, you can define your class as internal class as you want to access them only within the same assembly. And at the right hand side of the access modifier, optionally you can add the modifier. The modifier is optional for the class. The list of possible modifiers for the classes is static, abstract, sealed, partial. I will explain about all these modifiers of classes in the further sections, so timing we have to hold them. This is the complete syntax of creating a class in C#. So if you don't specify any access modifier, that is by default taken as internal, but there is no default modifier because all these 4 modifiers are optional. And then you will give the class name followed by all the members of the class such as fields, methods, properties, etc. The fields are used to store the details about the object. Methods are used to manipulate. Constructors are used to initialize the fields. Properties are used to set or get the values into the private fields. Events are used to raise the notification to other classes. And destructors are used to clear unmanaged resources. This is the briefing of all the members of the class. So as I told already, we have separate sections that explains each of these member. So time being, don't confuse about all these types of members. We will explain all these members in the respective sections. So creating a new console application and deleting the default code. I am going to create a class called sample and open the brace and close the brace. So by default this class is internal class because the default access modifier for the classes is internal. Optionally, you can declare the class as internal class or public class. So this public class is accessible within the same assembly or in other assemblies also where we have reference of this particular assembly. For example, we are going to add a new project in the same solution. So I right click on the solution, add new project, selecting class library.NET Framework, click on next and specify any project name, for example class library 1. Click on create. The class library is a collection of classes that will be compiled as a DLL file, that is dynamic link library, and that DLL file reference can be added to the console application. Then the console application can access any class that is present inside the class library. That means inside the class library 1, we have a file called class1.cs, so which has a public class. For example, we have a class called customer. So this public class of the class library 1 now can be accessible to console application if the console application has reference to the class library. As of now, both projects are added inside the same solution, but they don't have any reference. So inside the console application, you should add the reference to the class library. So right click on the project, add reference, go to projects and select the class library 1, click on OK. So now the console application called class example has reference to the class library 1, so it is able to access all the public classes of the class library 1. Inside the class library 1, we have a public class called customer. So this public class of the class library 1 can be accessible in any class of the class example console application because it has a reference, right? So I can access the customer class and I can declare any reference variable based on that. But in case if the customer class is an internal class, this customer class is accessible in all the files of the same project, that is in the same assembly, but the customer class is not accessible in any of the class of the console application project even though it has reference. That means the internal class is less visible than the public class. So now come back to the console application project. So in the sample class, we cannot access the customer class. It is saying an error saying that customer is inaccessible due to its protection level. But by making the sample class as a public class, now as the sample class is a public class, this sample class is accessible in any other project or assembly where it has reference to the current console application. we don't add the reference of the console application to other project. So it doesn't make any difference even though it is internal or public class because it is a console application. So the internal or public class is really useful only inside the class library but not in the console application. So overall in the projects, you will be writing set of reusable classes in the class library, such as you may write one class for business logic, other class for data access logic, other class for file access logic, etc. So those classes must be public classes in order to make them visible or accessible in the corresponding console application. So it doesn't make much difference if you make the class as a public class in the console application itself. It must be used in the class library. So we have understood the internal and public class and how to use them with class libraries. We will understand static, abstract, sealed and partial classes in the further sections. Now we are moving to understanding object. Objects are stored inside the heap. When the application execution starts, a new memory area will be reserved for that application, and that area is called as heap. Heap is by default empty. All the objects are stored inside the heap only. There is no any object that doesn't store inside the heap. And as you know already, when a method is called, for example, the main method is called, for the main method, a new stack will be created. Stack is by default LIFO, that is last in first out. All the local variables that are created inside the main method are stored inside the stack only. Why the stack is important for objects? Object is by default nameless. So in order to access the object, you require to store its reference inside the variable of stack. So that variable accesses the reference to the object, so it is called as a reference variable. What I am saying exactly is that since the object is nameless, in order to point to the object, you require a variable that stores reference of the object, that is the reference variable. So object is a collection of fields that is stored inside the heap. The reference variable that is present in the stack accesses the object. So how to declare a reference variable? You should use the class as a type because all the classes are types. So first write the class name followed by the reference variable name. The reference variable name is much like a normal variable name. It can be anything, but it should follow the variable naming conventions and variable naming rules, which I have explained earlier. So this reference variable is of the class type. For example, customer space C. Customer is an example of class. C is an example of reference variable. So in the static void main, I am creating a local variable of customer type, customer space C. And also in the class library, let me make the class as a public class, so then only it is accessible or available to the main method. So here customer is a type, C is the reference variable, it can be anything. This reference variable can store address of any object of customer class. It can store the reference of object of customer class only, but not other classes such as employee class or product class. The default value of reference variable is null. That means it doesn't reference to any object by default. After that, you require to create object by writing the new class name. The same syntax can be used for creating any number of objects. For any object, the same syntax. The keyword new says that we are creating a new object, and you should specify the class name for which you want to create object. So internally it will go to the class and find out the list of fields of the particular class, and with those fields an object will be created. For example, in the customer class, we have a field called customer ID, and also we have another field called customer name. These two are the fields that are members of the current working class. That means every time when you create a new object for the customer class, in each object of the customer class, these two fields must be stored. So here I am creating new object of the customer class. Again, I create one more object. So for each object, individual memory location will be created inside the heap. So we have a heap, and because of new customer, an object is created for customer class, which includes customer ID, and it will be by default initialized to the default value as we have given in the data types. So customer ID is of int type, so the default value 0 will be assigned to the customer ID, and customer name is a string, so the default value of string is null, so customer name is null. All the numericals are 0, string is null, and boolean is false. And because of new customer, again we got second object of customer class. Even for this also same list of fields are repeated that are declared inside the customer class. And for the second object also, the default value initialization repeats. When you assign a new value into the customer ID or customer name respectively, these default values gets overwritten. But as of now, the object 1, object 2 are nameless, so we cannot reference them in the further statements. For example, I am writing a statement here. I cannot access the first object or second object by writing some statement here. So since the objects are by default nameless, in order to reference them, you require a variable that stores reference of the object. Such a variable is called as reference variable, that is the importance of the reference variable. So in other words, the reference variable stores address of the object, making it easy to access the object. And you require two reference variables for two respective objects. That means I am creating C1, C2, two reference variables. In the first variable, I am going to store the reference of first object. In the second variable, I am going to store the reference of second object. So here we have created a class in the class library, and it is a public class. We have added the reference of the class library into the console application by right-clicking on the console application and saying add reference. And then we are able to access the customer class in the main method of the console application. We create the reference variables and we create objects. We can create any number of reference variable and we can create any number of objects based on the same class. Only creating the reference variable is not enough because it is just a reference variable. It is ready to store the address of an object. The reference variable alone cannot store the fields. By default, all the reference variables are local variables, and all the local variables are stored inside the stack of the corresponding method, that is the main method in this case. And all the objects by default will be stored in the heap, whereas heap is common for all the methods. So it doesn't matter in which method the object is created, all the objects are stored in the heap only. So if you write the same statement in another method also, the outcome is same. That means the objects are stored in the heap only. So overall, class is a model of object. Field is individual detail about the object. Reference variables are used to store the reference of object. One reference variable can refer to only one object. An object stores the list of fields that are given by its class. All the objects are stored inside the heap only. Reference variables are local variables, so they are stored inside the stack of the current method. This is what you understand in this lecture. In the next section, we will deep dive into fields and understand the different types of fields.